So we'll go share screen here. And let's go on this one. Okay. So if I had to break it down into terms, okay, these would be some of the terms that that would come up, okay? And so, I mean, the main one is the object itself, okay? And if I was talking in English or teaching you English, that would be my noun, okay? That would be our noun. And then if we look down a little bit here, I've got where do I got it? If we are describing that noun, once we create the object, then we can describe it. And those are called the attributes. Or if it was, again, if it was a noun, this would be our adjectives if this was an English class. Same thing with methods. Methods are things that our object does. So those would be our verbs, okay? So we're going to create these objects. We're kind of like playing small letter G God, because we can create the object in we can create a person, for example, okay? And our person can have whatever methods and attributes we want that person to have. We can have, vehicles, okay? And we can put in things like how many tires does it have? How many horsepower is it? What kind of engine does it have? What color is it? Those would be all attributes of our object, okay? And then this class here, that's like the blueprint we're going to build that object off of, okay? What is our object going to look like, okay? And we can make it look however we want. And we can call it whatever we want. In fact, maybe the object that we create is something that doesn't even exist today. It's abstract, let's say. But it doesn't have to be. We can create classes for houses, people, animals, whatever we want. And then we can decide how we're going to describe them, et cetera, okay? We can make, once we have this blueprint, the class, we can make as many instances of the object as we want. In other words, if this was a blueprint for a class called house, in the real world, we could build as many houses as we want from one blueprint. Okay. The term instantiate just means to create the instance. When I create one, I create an instance of it, is to instantiate. Encapsulation. I mean, most of you, I'm assuming, drive cars, okay? And when you drive a car, how many of you know what is the firing order of the pistons on your car? How many of you know how the computer that makes your engine fire works? How many of you know how the automatic transmission in your car works? Or the clutch if you have a stick shift? Then how can you drive? If you don't know those things, how can you drive?
Because of abstraction.
Because of abstraction or encapsulation. Because they don't want you to know what's under the hood. In fact, the new Mercedes, they don't even give you an oil stick to check your own oil. And most Mercedes have a big plastic shield over the top of the engine. If you raise the hood, all you see is a piece of plastic under there. Okay, you don't see the actual engine. Okay, so they're high, but you can go in the car and you can turn the key and put it in gear and it drives. Do you need to know what's going on underneath the hood? No. Does anybody in here know what's behind when we in Python, when we type the word print, okay? How does it know to print that? How does it know that whatever we put in those parentheses should print out? Do we need to know that? Probably not. You don't need to know that. Do we know how try works? What's the code behind try? Okay. We don't need to know that. Okay. So that's kind of what we want to do. What people don't understand is when you're learning programming like this, a lot of times you're playing the part of like 4 different people. If I'll give you a comparison to home building. If I was a speculator and I wanted to build a subdivision, okay, so I'm over here and I want to build houses, and I go to, where do I have to go? I have to go to an architect, and I tell him, hey, I want 3 bedrooms, I want this, and he draws a blueprint. Okay, then that blueprint has to go to a contractor that does what the blueprint says to do. Okay. Then that blueprint or that carpenter builds it, and then the user buys the house. It's the same thing here. Okay. We can think of what we want in our class. Then we have to put that in the class or in the blueprint. Then we have to build from the blueprint an instance of the object. In other words, we're building a house. And then hopefully at the end, a user can use that to get information from our program. But since we're single people, we're doing the parts of all 4 of them. So we know what's under the hood. Okay. And that isn't what it's like in the real world necessarily. Because a lot of times I can go and I need to write a program. I can go and get well, you've seen it. When you type in input, okay, you have no code that says, hey, get the information it says for input and accept a variable or something from the keyboard, store it in this variable over here, do you? Do you know how that works? Because I don't. I've never looked it up. Anything that's a keyword is there's a blueprint out there somewhere. When we instantiate or we make we use that library or whatever, and it just works, right? It just works. We don't know how that works, so we plug it in our program. We plug it in our program, and then, hey, you know what? It works. Dave, did you have a question? Or?
Yeah, is that what the compiler does?
In a sense, not. There's just, again, it's more what the import does a lot of times. And the other thing is that these programs a lot of times have certain things built in them. Okay, like there's different types of Python, right? And if you use certain types of Python, you'll have the ability to do graphics, let's say, or without having to import it from another library or another object. You don't have to instantiate it or anything like that. It's already in the type of Python in which you're working. Okay. So if it's a really stripped down one, if they're trying to get as least the smallest footprint as possible, you might not have all the bells and whistles you would have in some of the other versions of Python. Okay. And of course, yeah, when you compile it, it has to have everything that you specify in it has to be able to get, it has to be able to pull it from somewhere. Okay. My scenario down here on chairness, let's see, what else didn't I cover? Setters and getters. Your book calls them, I forget what they calls them. It's something, oh God, they got a name for them. When you're reading this, I don't have my book laying here. When you're doing this, setters are, what is it? The book has your book has a different name that changes. It's the term for changing. So setters are what we use to change the value of a variable or an attribute, better yet. Okay. So we need setters to change the value of attributes. And then when we store those, we have getters that go and get them when we want to display what's the value is. Okay. Setters and getters. And those are part of the object. And the last thing down here, I think, is Plato's allegory of the cave. So my scenario on objects, I took Plato's allegory, I stole Plato's allegory of the cave. The allegory of the cave is in Plato's Republic, 7th chapter. And basically, Plato uses it to describe why philosophers should be king. In my case, I'm going to use it in a little bit different context, because what it is I'm sure most of you, when you were kids or whatever, made shadow puppets on the wall, either with a flashlight or something. You know, oh, look, there's a bunny, or there's an alligator, you know, that kind of thing. Well, in Plato's allegory of the cave, humanity is chained up arm in arm. Okay. So we're chained arm to arm, and we're all facing this wall in the cave. And we can't see what's behind us. Okay. And every once in a while, on the wall in front of us, there's an object projected from behind us on the wall. We think that's reality. So every once in a while, you'll see something on the wall, and it has 4 legs and a seat and a back. And everybody goes, chair. Okay. And because we've seen it day after day, and we know that if it looks like you could sit on it, it has 4 legs and a back, that's what we call a chair. Now, at some point, and I'm not talking language here, you know, I don't know, maybe there's a can up there and I call it beer and you call it cerveza. We're talking about the same object. Okay. I'm not talking about language skills here. So everybody knows that's a tin can or a beer can or a chair. And so that's our reality, what we're seeing in front of us. And, but one day, one of the people in the chain, the philosopher, gets loose, and he's able to turn around and see that, in fact, there's some little gremlin or whatever that has a fire going behind us. And every once in a while, he puts an object in front of the fire, which is projected on the wall. So he comes by, and here's a chair. He's carrying a chair. He puts it in front of the fire. It projects it on the wall. And everybody in humanity says, oh, yeah, that's a chair. That's a table. Okay. Things like that. But now the philosopher knows that what we're seeing isn't reality, that somewhere at some time there was the almighty chair. I don't know if it was in a cave. You know, you got 2 cavemen sitting around and they stack up a couple blocks, and one goes, chair. You know, the other one says, okay, we call this a chair. Okay. And that was the almighty chair. And it has chairness. I made that word up. It has 4 legs, the back, and then so I call that chairness. And like a ballpoint pen would have penness or whatever. Okay. And yeah. So our object, or our instances of our object, I'm sorry, the instances of our class are those things that are projected up on the wall. Okay. And we can have as many of them as we want. Okay. So every time one goes by the flames, we instantiate a new one, et cetera, et cetera, et cetera. Now, in Plato's allegory, really what happens is the philosopher gets loosed. He goes, sees what's happening, goes outside, is blinded by the light, the sunlight, comes back, wants to be back chained up, and he's trying to convince everybody else that what they're looking at is not reality, that only philosophers really know what's going on. At least that's my interpretation of Plato's allegory of the cave. Maybe not a professional philosopher's. So we're going to create objects and give them nests, chair nests, or whatever, person nests. We can create people. Okay. Inheritance works just like when the biological inheritance works. I can inherit from one class into another class its attributes. Okay. So you might have a super class that has, let's say, a super class for vehicles. And in my super class for vehicles, I might have an attribute for name. I might have an attribute for what kind of power does it have. And I might have a attribute for how many wheels it has. Okay. Then from that one, I can make a subclass, okay, of trucks, okay, and I can add on. I already have the superclass that I'm going to inherit from that has the name of the truck, how many tires, and how it's powered. But now I can add other things. I could add what is its hauling weight, what whatever, what color is it? Then I can make another one, because that superclass can have multiple kids, right? So I might have one for bicycles made out of that. I might have one for motorcycles made out of that. And likewise, my one for, let's say, trucks might have a child called pickup truck that can even have more attributes. Okay. But it works in a downhill hierarchy. Okay. You can't, in other words, my parents did not inherit anything from me except headaches and high blood pressure. Okay. And those aren't biological, I don't think. All right. So it only works one way. It's a downhill thing. Your parents can't inherit from you for the most part. So that's our vocabulary list. So as you go through programming, if you've taken Java or C++, those are also object-oriented programming languages, as is, believe it or not, Visual Basic. Some people would argue that, but it is in fact or can be a object-oriented programming language. Any questions on that? Is everybody asleep yet? All right, I'm going to stop sharing that. I better turn on the old security thing now that everybody should be here. Enable waiting room. There we go. Okay, so we got objects. So we're going to deal in objects. And the one I'm going to do with you tonight is we're going to use something called pickle. Okay. And it's a serialization. We're going to change the input and output into binary, I believe it is, or something. You can't read it necessarily without a program. Okay. Because it'll just look, if you try to read it as text, it'll just look like a mishmash of weird stuff. Okay. So I thought we'd do that program. I gave you 2 other small programs to do. So this one won't be too bad. We're getting down to the end, okay? So if you owe me anything and you want to get graded for it, this is week 13. I have lessons for 14 and 15, I think it is. And then the 16th week will probably be a makeup, or if I have one, it'd be an extra credit type of thing, maybe. Excuse me. I had a rough day. I had to move 6:30 this morning. I was moving furniture for my son from one house to another. And then a buddy of mine decided that he was getting rid of a like $1,000 elliptical. And he says, if you want it, come and get it. So now I have a new elliptical. And so of course I had to try it out today because I've been using the same one for over a year. And this one's a lot harder than my old one was. So about killed me before you guys got here. Not that you need to know that, but I like to make it personal. All right, so let's go over to our buddy Thawny here. And let me see what else I got for you here. All right. So let's do this. Let's go ahead and, can you guys see that, by the way?
Yeah.
I can see it.
Okay. Don't sound so excited. It's crazy. All right. So we got our new one here, and let's call it, oh, I don't know. Oh, I know what we can call it. One of my favorite things. Let's call it, how's that? Acme Company. And file. This one will be Acme employees. And today's date, 4/22/2021. Author and purpose. A program to use a employee class which allows the user to search, add, and modify, delete, employees. All right. And we're going to go ahead, start off. We'll import pickle. And that should just allow you to do that. And we're going to put in our global constants as lookup. And add. And change. And delete. and quit. Okay. And let's name, we'll have a global constant for the file name in this case. I'm not gonna make you go look it up. So we'll say file name will be equal or assigned as employee dat. Notice that it's not a text file. Okay. And then we'll do main function as define main and put our, let's see here. Okay, so now we're gonna have a method called load employees. So we're gonna say employees is gonna be assigned load employees. Okay, so to do that, we need a method for load employees. And again, I'm going to do my best to explain what everything is as we go. I'm hoping that's my wife with my coffee. I don't, again, if you don't know me that well, I don't function well without non or endless cups of coffee. So this is where we're going to try to open our file here. And it'll be an input. And again, we had this where it's a constant, right? So all we're going to do is open, and then we can just put file name here. And R and B. So that's a new one, right? And I believe it stands for read binary. Okay. And it's compressed in a pickle. So we're going to say unpickle it. Whoever came up with this name, I have no idea at all. I'm sure you could look it up if you wanted to. And we're going to create a dictionary called employee. And we'll just call it employee dict is equal to, get a load of this, pickle dot load. That's input file. Okay. And then we can close the file. So that's kind of strange, right? And of course, we need an exception here just in case it doesn't find that file. And if it can't find it, make an empty dictionary so it doesn't crash. So it'll be EMT. I guess maybe the first time you run it too, if you didn't have a file set up, we could employee, have to be able to spell employee, Doug. And then we'll just put in empty braces like that. Okay, return. And then we will, since we called everything, we need to return the employee dictionary. Okay. And I think that's the perfect little. Okay, so we got that. So this is, so let's just put a note ahead of on top of that. Get employee dictionary. All right, now let's put a menu in. So we're just going to initialize our choice variable. So it'll be choice will be equal to 0 at this point. And then while choice is not equal to quit, what do we want to do? Well, choice will be equal to another get user choice. Okay. So now we need a routine to get user choice. So we're going to go down and define get. Not passing anything here. So now we're just going to create the menu and get user choice. Print and print. Um, and then something like that. God, I should put a try in here, but I'm not going to because we don't have a lot of time. That'll work. That works, I think. Oops. Blah, 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 blah. Okay. Let's go down here, type main. And will this work right now? Let's just see if this will print. I don't know if this will blow up or not. I think that's what I called it. I should look probably first. Hang on a second. What do I call it? Acme employees. Yep. Okay. Now I'll save it. Let's see if it'll affect run. I thought I had that. Load employees. Oh, we're not going to find that file, are we? Get user choice. What did I call it up here? Oh. Okay, so we need to fix this here because that's so get user choice. There you go. And you can see it printed out 1 there, 2 there, 3 there, 4 there. 5 should quit the program, and it does. So it does work. Okay. So that checked out, so we no longer need that. Okay. Okay. So now let's see, what am I going to do? Okay, if choice is equal to lookup, then what we want to do is look up employees. Else, if choice is equal to add, then we want to add employees. Else, if choice is equal to change, we want to change employees. Else, if choice should change, add, change. Oh, delete we needed yet, right? Okay. So what I did there, basically, we can go ahead here and rem these out for now. And we'll add them back in one at a time, I think. Okay. So now we need to look up employees, okay? Need to look up employees. And so we're going to go down here and make ourselves another method. And these surely could be in a different file. And then we're going to get the employee ID to look up. So this thing's all based on a key. Okay. So ID is input, enter an employee ID number. Make sure, like on all these where I put in the semicolons for waiting for input, make sure you put a space here, because if you don't, then when the user sees it, it's no big deal, but they're typing right on top of your semicolon. Okay. And then, so I want that ID, enter that, look it up if found, data will print the string method. Okay. So then we're going to go here and type print employees dot get ID, comma, let's see, if it wasn't, then we want to print the specified ID number was not found. Okay. Employee name. Okay, that's fine. That's fine. Delete, that's fine. Okay.
So that second statement works as like an exception is in case that like
Yep.
ID is not found. That's interesting.
And hopefully that's going to work for us. All right, now we're going to go ahead. We got a couple things we need to do. We're going to add another file here. Okay. And let's go back here once real quick and get our header, our internal documentation. So I'm going to Control C that, bring it over here and pop it in here. And this one is just going to be called, what do I want to call it? I think I called it EMP. Let's just do this, EMP. And this is the a class to instantiate a employee object from. With attributes. Okay, and then, so let's save this as EMP. Crap, I already have one. No. You guys make yours EMP. I'm going to make mine EMP2. Okay. All right. So in these, there's a couple special. So we're going to call this class employee. Okay. So again, this is our blueprint for an employee object. Okay. So then there's these things called constructors. And these are special methods to allow instantiation from. Okay. And we define them by doing this. It's underscore underscore INIT underscore underscore and then a name. And most people just use self. And then we're going to have the name is an attribute. The ID number will be an attribute. The department they work in is an attribute, and their title. Okay. And their title. And so now, when somebody puts that in, it is assigned to, we have this thing called self, and it'll be self. Is that a single? I can't remember if these are singles or doubles here. Let me see if that makes it worse or better. I think it's a double. I'm much more familiar with Java than I am this one, but that'll work. Let's do doubles for now and see what happens to us. We can always come back. So then a double name is equal to the name somebody provides. Okay. And then self again. And this one is ID number is equal to ID number. And why are they like that? Why are they using the same variable name for this two different things? Well, that's why we put the self out in front of it so that we know it's this one, the one in the, this is what's being assigned to it. And it's assigned to this attribute that's in self. And so we got self department. And I tried changing self to poop and it works fine as long as you're consistent. So you can make it whatever you want, but most people just call it self. Okay. All right. So now we're going to come down and define setters. Okay. So set name is self name. And then we're going to say self name is equal to, there's assigned name. Then we're going to go down and do the same thing. So we have these sets first. Some people put the sets and gets next to each other. In other words, a lot of times I would do it this way. Then I would say get name. Okay. And then I just need to put self in here. And then, whoops, I forgot my, and then down here, it'll just say return self name. And then I would move on, because then I could put in nice dividers here too. I could say, okay, here is my name stuff. So here's my name stuff. And just makes it easier to read. Then I can go down here and do ID number, let's say. Oops. Set, how do I have that set up? Let's set up ID number like that. And then self ID number. And then self dot ID number equals ID number. And then I need my get. Then we come across the ID number, and then we got department, right? Oops. And we just keep going like this. To create our objects, or our attributes, I'm sorry. And then we got title, and we'll be done. You understand that what's up here in the argument is like here, these two are the same variable. This one is up here in our constructor. Okay. This one belongs to employee. All right. So they are different variables here. So I got that as the title. Is that right? I think so. All right. So then we have define get title. That means go up to where are these and get that value, okay? And then return it to wherever it's being called from. And I think that's right. Now, we want to print these out, and we want it to be in such a way that it's consistently prints out the same way all the time. So we're going to create this string thing. So it's define 2 underscores, str, 2 underscores, and then self in like that. And then we'll have something called result will be assigned name. And then plus self dot get name plus slash n id number plus, oops, come on, plus self set or get id number plus department. Okay. And then, of course, I'm going to make sure I save this.
Hey, Doug, quick question.
Yeah.
Do you know if PyCharm has um like a feature like NetBeans where you can just automate this?
Probably does.
Yeah.
You should, again, if you're using something like that, if you've never done NetBeans, once you create this up here or set up your variables, all you do, your attributes, you right click and you can say auto or insert code, and then you choose what attributes, setters or getters you want to put in, and it types all this out for you. I would still check over it and make sure it's what you want though. Okay, when you do that. But that's a good point. I don't know if PyCharm has it, but I would say probably somebody out there does. And I'm going to be, again, I'm just a little bit anal here. Since I capitalized all the other ones, I think I'm going to do that here. Okay, so I got that. I think we're good there.
Is there a reason that get name is capitalized and the other ones have underscores?
I probably didn't, because I probably misspelled it. Yep. So this is wrong right here. Good catch. It should be just underscore name. Again, it's a different naming convention than I use when I teach Java. So you'll have to excuse me on some of this stuff. And then I'll resave that.
Oh yeah, and line 18 with self name, is it supposed to
Yeah.
have the dot on there? Or like it's self dot underscore name is
Self. Yep.
all right.
It's another good catch. Anything else you see? Okay, now I am going to put in our in your assignments, okay? I'm going to put a file in there for you, okay? And it's an already made up, it's the file that is employees data, okay? And I already have some employees in it. So I'm going to put that, and you're going to have to go put that in wherever you're doing your Python at, okay? So let me do that real quick. And I will add a file here. If I can find it. I can always find it. Let's see, EMP, employees. That's the data right there, I think. Or is that it? That's it. Okay, and then I'm going to submit it. Okay, so now what I want you guys, you should be able to see that file in your Blackboard. Okay. You should be able to see that. You see it? Go to Blackboard and there should be an EMP file there. Or
Oh,
employees
I see
dot,
it.
yep, employees dot data. You're going to need to put that in the same file that you are putting your Python in.
I don't know if my Blackboard is broken. Lesson 13 is like all the way at the bottom with the where the Blackboard help is on the left side.
Oh, that's me. Hang on, I'll fix that. Okay, if you refresh now, lesson 13 should be back up at the top. I apologize.
Good.
I'll try something here. I thought I put somebody in there. Unless I got an old file. I'll try it one more time here. That's interesting. Well, it looks like we might have to add our own. I think I pulled out one without any data in it. So we got to put our ad in before we can see this thing work. Okay, is everybody good? They found the file and okay, you should be able to see me again. I'm going to just go ahead and comment out my ad. And I'm going to go ahead and add a method down below. So here we're going to get the employee's info.
Are we supposed to import the EMP?
Oh yeah, we need to do that too. Thank you. Way at the top, you're just going to say import EMP. You know what? Maybe that's why my thing wasn't running. Let me run it again. Before I do that. Okay, so that shouldn't hurt anything. Let me save that and then, oops. Acme employees Pidine main. Okay, what happened there? Blah, 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 blah. Acme employees dot py. What'd I do? Oh, there's nothing in here. Okay, let me try this. There we go. So now if I type in 1, and one of the numbers I had established was 1, 2, 3. No, I must have got rid of that file. 119 was another one. Crap. Okay. So it looks like it's empty, but that's okay. Control Z my that. EMT is up there. That's fine. My ad is back in. So now let's get some data and see if we can get this thing to work. So name is going to be input. So kind of a cute little message that they've been added. Blah, 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 blah. So let's save that and run it. And if I hit 2, it says, so I'll create myself. I'm employee number 100. And I work in the warehouse. Whoops, I don't have my title in there. That's not good. I want to see if it's going to look it up anyway, though. There you go. Okay, so then we'll quit. I've got an error somewhere here. I forgot the title.
I forgot to put input before the statement.
Oh, look at how good you guys are. Okay, and I'll save that. And now I'm not going to go ahead and create another one. So let's go to and Mary Smith. And Mary Smith is 101, and she's an administrator, and she is accountant. And now if I type in 1, and I want to look at 101, there's Mary Smith. If I want to do a 1 and I look at 100, why isn't that writing those? It's like it's not saving them. And I wonder if that's because I didn't put in my save stuff yet. I have not pickled them. That is what's wrong. Define save employees. Oh my gosh. Okay. So that's what we're missing right now. That's why it's not coming, why I can't save them. Okay. So let's put that in right away before we even go on. We're going to run up at the bottom of our, right here, up in our main. We need to pickle everything. Okay. And so we're going to say here, oops. Geez, Doug, you're all over the place. Okay, so we're going to say pickle the dictionary. And so then we do save employees. Whoops, employees. Save employees. I think that's good. It's a lovely name. And then let's go down here and right here. And this is All right. Okay, define, save. Employees. Employees. And then output file is equal to open our silly little file name for writing in binary, like that. And then we want to do, and this is a great word here, you want to do a pickle dump of employees to our output file. And then we'll go ahead and output file close. Cool. Get rid of some of this space down here. Now, let's go back in, save that. All right. And I'm going to add a file. So this one will be me again. I'm just going to make it Doug Peterson this time. And my number was 101. And the employee department I work for is the warehouse. And I am a forklift driver. And then I'll add another one, Mary Smith. And Mary Smith's number will be, oh, I made myself 101. Mary Smith will be 100. And she's an administrator or an administration. And she's an accountant. Okay, so now I can look them up. Let's see here. If I look up 101, I get Doug Peterson. If I look up 100, I get Mary Smith. And now I'm going to quit. And then I'm going to go ahead and run it again and see if they're still there. And that was 101. There I am. So it's now saving it to that file that we have, okay, to our employee data file. And if you were to go in there, I'm not going to waste your time right now, and look at it, it looks nothing like what we're looking at here. It doesn't look like a text file, okay? Okay. So yeah, so we got that. So then I'm going to quit there, and we should be ready for, let's see, we did add, we did look up, we're ready for change, I think. So I'm going to run up to the top. And undo my change here. Okay. So dedent, oops, I'm sorry. That's not what I wanted to do. I wanted to uncomment. There we go. So that looks good. And we'll go down to add another. I'm going to add it in right here, though, above our save and pickle. And it was define change. It was a simple name. And again, we'll use employees. And ID is equal to input. Enter the employees. You can just make it employee ID. I did this -S thing. Takes you more time to type that than it's worth, really. Okay, and then if ID in employees, what do we want to do? Well, we're going to change everything. So what I'm going to do here is just go up and copy this right here. Come down here. If, where's my if? Right here. And paste this in. Okay, so this needs to be indented correctly. So I got all that. And then we can come down here. And where was that at? In my ad, you can just take this line and bring it down. And then we're going to say employees ID is equal to the new employee, which it isn't really a new employee, and then print employee information updated, let's say. And then else, we can just say print the specified ID number was not found. Okay, and then we can see if that works. I'm going to save. And there. And I should be able to just go to 3. And I was 101. And so we get to do Doug Peterson again. ID number. What did I do there wrong? I need to quit this one. Let's see. Because I put in too much info, I think. Let's go back and take a look at it. Okay, change. I need if name, enter part. Oh yeah, I didn't need an ID number. Get rid of that line here. I don't need that because I already got the ID, so it makes no. So I got name. That should be better. Save that. Run it. Oops. Okay, so 3. Okay, so now 101, I think I was. And Doug Peterson. And my department, now I'm going to move myself to transportation. And I'll be a driver. So now if I look me up, I do 101. And I'm now a driver. So our change thing is working, okay? So we'll get out of that one. And that leaves us delete, I think. So we go up to the top, undo our delete here. run down. Right underneath our DF define change, and we'll define delete. And of course, it's with the employees. And ID, again, it'll be input, enter the employee. Got that. And then we can just say if ID in employees. This is cool. All you have to do is type DEL, employees ID. Those are brackets, okay, not then print. Employee. I think I'm going to do this. Employee. Can I just do plus ID? Or can I use commas? I don't know. Okay. And then, of course, over here, else print. I think that should work. So now if we run it, ooh, that's not good. Blah, 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 blah. It doesn't like that. Define delete. Unindent. Okay.
I think def delete employee has like a space in front of it.
Oh, there it is. Yep. Thank you. Crazy. It's crazy. I'm telling you, it's crazy. I wonder, these are all off by one then too. Geez, there's still a, so you get, and I'll just indent them using the, all right, now I can just tab them over. Save. Run. There we go. And I'll go ahead and say, okay, number one, I want to see number 101. There's Doug Peterson. I go to 4. Say 101. Play 101 was deleted. If I try and look up 101, not found. Okay. And that looks like a wrap, guys and ladies. So you're going to want to zip up these 3 files, okay, and submit them this week. Anybody need me to go anywhere?
Could I see the in the EMP file, the change to string? I'm
Yep.
getting a syntax error for that.
That's just usually a normal typo, little typo somewhere.
Hmm. Oh, I forgot the return result. Ah. Thank you.
Anybody else? Okay, I'm going to stop sharing and I will stop recording.